You're watching a Hanford Communities issue briefing, highlighting important environmental cleanup issues at the U.S. Department of Energy's Hanford site in southeastern Washington, issues affecting citizens of the Pacific Northwest and the nation. The Hanford Communities organization was established in 1994 and is comprised of the communities surrounding the Hanford site, forming one voice to advise the Department of Energy on important transition and cleanup issues.
Work is underway at the Hanford site in southeastern Washington state to keep workers, the public, and the environment safe from highly radioactive byproducts from the site's Cold War history. Beginning in 1943, the Hanford site produced plutonium during the Manhattan Project in World War II. Producing nuclear materials for America's weapons program continued over the next 40 years, resulting in a legacy of contaminated buildings, soil, and waste, including millions of gallons of waste stored in underground tanks. In the 1970s, radioactive isotopes of the chemical elements cesium and strontium were removed from the underground waste tanks to reduce the amount of heat generated by the waste inside the tanks. The waste was pumped from the tanks to Hanford's B plant, where the cesium and strontium were removed. These elements were placed in sturdy stainless steel capsules and stored under several feet of water in a building attached to B plant called the Waste Encapsulation Storage Facility, also known as WESF, for safekeeping and monitoring.
So this picture is a diagram of WESF, the first floor of WESF. You can kind of see over here is the pool cell area where the capsules are stored. Over here are the hot cells, or the process cells, where the capsules were produced.
Jan Pennick is a project engineer at WESF. She is with the Department of Energy's contractor, CH2M Hill Plateau Remediation Company, also known as CH2M.
This is a capsule. This is actually, it has an S number on the top, so this is a strontium capsule, but the cesium capsules are almost identical. They're slightly different dimensionally. And obviously there's no radioactive material inside of this one, but this is actual capsule material. And the capsules are made out of two stainless steel tubes. So you have the inner one and the outer one. The cesium chloride or the strontium fluoride salt would go inside the inner capsule. The capsule would have been inspected. The top cap would have been welded on the end of it. It would have undergone a helium leak check. And then assuming that the weld inspection was good, it would have been put inside the outer capsule. Again, the cap would have been put on the end and welded, and then it would have undergone another inspection just to make sure that the weld was good.
The contractor is responsible for monitoring and maintaining all of the nearly 2,000 highly radioactive capsules stored in the facility's concrete basins, called pool cells. The facility is located in the center of the Hanford site in the 200 East area. The highly radioactive capsules are under 13 feet of water, which provides shielding to workers and provides cooling to maintain a safe capsule temperature. Due to the heat given off by radioactive decay of the cesium and strontium in the capsules, the water in the basin must be circulated continuously to keep the capsules cool. An eerie blue glow can be seen in the WESF pool cells when the lights are turned out. This glow is known as Cherenkov radiation. The glow is caused by radiation from the cesium and strontium coming from the capsules, passing through the water.
Right now, there are probably slightly under 94 million curies of total activity in the pool cells, which is a pretty big number, and that adds up to about 1/3 of the cesium and strontium on the Hanford site.
CH2M is safely and compliantly managing the capsules and has improved the safety of the storage facility in the past few years. In 2012, CH2M engineers assessed the heat given off by the capsules and the potential impact in the unlikely event of an earthquake more severe than predicted for the Hanford site. Based on that assessment, workers moved many of the capsules within the pool to distribute the heat load more evenly. This will allow for the greatest response time possible in the unlikely event of a loss of water in the pool cells that could possibly cause the failure of either the pool structure or the capsules. The Department of Energy, or DOE, is committed to safely storing the capsules until a disposal pathway has been identified. In the meantime, DOE and CH2M are preparing to move the capsules out of the pool cells and into dry storage containers, called casks. The next step in these preparations is to design and build casks, along with procuring equipment and modifying the WESF building to support moving the capsules out of the pool cells. Dry storage casks have been widely used in the nuclear industry to safely store spent nuclear fuel, which also generates heat. Modifications to the WESF building include current work to upgrade the facility's ventilation system so it can support storing the capsules until they are moved to dry storage, beginning as early as 2022. Workers are also preparing to immobilize contamination by pouring grout in portions of the building's old ventilation system, along with pouring grout in rooms that shielded workers from radiation, called hot cells, that will no longer be used.
So here are the hot cells where the capsules were produced back in the 70s and 80s. We have 7 hot cells, A through G, and A through F cell are the cells that are going to be grouted. The exhaust ventilation duct is actually located below these hot cells underground, and the K3 HEPA filter is outside on the south side of the building, so it's kind of off in this direction. So hot cells A through F, the underground ventilation duct, and the K3 HEPA filter pit will all be grouted in order to stabilize the contamination that's left over there.
The hot cells were used to handle the capsules remotely during processing. Moving the capsules to dry storage casks would greatly reduce the risk to Hanford site workers and the public from the possibility of a release of radioactive material in the unlikely event of an earthquake stronger than what is predicted for the area. Dry storage also provides significant cost savings over a period of years versus operating a nuclear facility that is more than 40 years old. For those reasons, the Department of Energy and CH2M are moving forward with plans to transfer the capsules out of the pool cells at WESF. This in order to ensure the safe and cost-effective storage of the capsules until a permanent disposal plan is identified by the federal government.
To find out how you can become more involved in this important regional issue, or to have a Hanford Communities speaker talk to your organization, contact the Hanford Communities at 509-942-7348 or by fax at 509-942-7379 or visit our website